Okay, welcome to week 3. Today we are going to do our first milling toolpaths, and there's going to be a lot of information in these tutorials. It's going to take some time to go through, so just make sure to put some time aside this week to really dig into this. It's going to be one of the longer weeks as far as material is concerned, but if you're able to get through all of these exercises and tutorials, you're going to be in really good shape. So we are going to be doing the 2x pocket in this video, 2 times pocket, and you'll recognize it from the previous labs because it's the same part that we were drilling holes in earlier. So nothing really extra to look at as far as the print is concerned. There are a lot of slides here. There's a lot of extra information in here that we may not cover specifically in the video, as I'm focusing on just showing you the actual steps in Mastercam. However, make sure that when you do this with yourself or by yourself that you take this PDF and really dig into it and read everything that it has to say as you start working on the part. So what I need to do is open a new Mastercam, which I have right here, and I have already downloaded the files required for the tutorial, which is 1-1, or I'm sorry, what is it? It's 1-1 mil 2 times pocket. So I'm going to go ahead and file open, and I'm going to find the Mastercam file that I downloaded off of Blackboard, which for me is going to be in week 3, tutorial, and then here is my file that I'm going to begin working on. So again, a lot of the setup stuff has already been complete. We'll be covering some more of the setup process during the in-person labs. For right now, the solid model is set up. These 0 points are set up. Your levels are established, and your plane for Op10 is already created. So again, we'll be going over that in the labs and in other videos as well. So to start, just as an overview, we need to make level 100 active, which is the part, which is great. We also want the wireframe we want to make edge curves next, and that's not really covered in the tutorial apparently. Okay, so let's do edge curves. I have the part visible, okay, and I also have edge curves turned on. You'll notice that there are no entities for this. So what I want to do is create edge curves. What that will do is that will draw a wireframe profile around all the solid geometry, and that might be helpful later on down the road when we're doing some chaining. So edge curves is located in wireframe. Again, notice that my level 400 is active. I'm going to select curve all edges, which is again in wireframe and then curves. It's going to ask us to select the solid model. We want to get everything, so I'm going to zoom out and do a pick box to get all the model. I'm going to hit end selection, and then you'll see that we have a cyan outline, a 2D outline of the entire part, which I'm going to click OK. Good, and that's fine. The blue wireframe is good on that, and we have 100 entities now on edge curves. So that is what we are going to want to have here. So go ahead and save that. And now we'll move on to roughing the through pocket. So there is an overview slide on page 6 that I encourage you to read first. So go ahead and pause this video and read through that. It explains the differences between roughing and finishing and why we do both things. Once you are finished reading through page number 6, we're going to start on slide number 7. We're going to go to toolpaths. I'm going to make sure that our insert flag is down the bottom under pectoral, which it is. And we're going to go ahead and hit dynamic milling, which is this guy right here. We're going to click on that. Now this is going to be your first foray into major chaining work. So chaining is the process of selecting geometry that will allow Mastercam to compute your toolpath. There's a lot to this, especially in this particular chaining dialog box, so you're going to want to remember where this is in the lecture and refer back to it often. We are going to click on machining regions, but before that we're going to ensure that stay inside as far as the strategy is checked. So that means anything that we select for a machining region, the tool is going to stay inside of that region and it's not going to be allowed outside of it. So we're basically creating the envelope that we're going to be machining within. So stay inside is selected. We're going to select machining regions. And now we've entered the chaining dialog box for machining regions. Now we are going to use the wireframe geometry that we created in order to chain the geometry we'd like to do. So that means we're going to switch from the 3D pick options to C-plane, construction plane, which is a 2D. And you'll see that the icons are a little bit different, but this is still the chain icon. Okay. We're going to make sure that our level 1 and 400 are active, okay, which they are, just double checking. Now we are going to chain according to page 11. We're going to chain the bottom of this toolpath right here. So by selecting chain in C-plane, when we click anywhere on this bottom area, the areas that are connected to it are all going to highlight. So if I select this one chain here, you'll notice that it selects the entire path all the way down at the bottom. Okay, that's what a chain is. It just highlights the entire continuous profile. Now partial, there are some different ones down here that we can play with that we're going to look at later, but for right now what we want to do is we're going to machine this pocket first. Okay, and again, this is all on page we're on page 11 right now so far. Just change the way this is looking at on my screen. There we go. Good. So that yellow dotted line means we have it selected. Moving on to page number 12, we're going to, again, this dialog box looks a little bit different, so this is one of the changes between older Mastercam variants. However, we are still using the same checkbox. So the green checkbox means OK. So now you'll see we've selected one machining region. We still have stay inside selected, and that is the only chain that we have to perform right now. So we're going to go ahead and click OK, and it puts us into our high-speed toolpath dialog box. Okay. If you need to, go ahead and pause that and go back and look at it again. We are now on page 15, or 14 technically, so we're using dynamic mill, one machining region, and we're staying inside. So we are going to use a 3/4 roughing end mill, which means we have to go into our library and find it, or in fact, actually we're lucky here because we've already done this. Well, this file has already been preset up, so you can actually see that there's a 3/4 roughing end mill already in the library and active. So all we need to do is highlight it. It's tool number 4. Now we're going to go ahead and go into the comments, and we're going to add rough through pocket. And we're going to put 0.020 XYSFF. Now, again, reading through page 15, XYSFF is a stick standard. It's not like an industry thing. It stands for stock for finish per side in the X and Y axis. So meaning we're going to leave 20 thousandths for finishing. And I just want to make sure, I'm going to put a space in there. So we're going to leave 20 thousandths for finishing. That's basically what that stands for. Okay, and again, this is just a stick specific thing. It's not something you have to remember. When you're at work and you're working for a company, they're probably going to have their own specific nomenclature they're going to want in your CAM files. So not too big of a deal. So The pocket is 0.710 deep, which means we want to use as large an end mill as possible to minimize deflection, meaning that the tool is going to be sticking out of the holder quite a bit. And if you're holding it farther up, the more side-to-side play you're going to get. So you want to make it as rigid as possible, and the only way to do that is to make it bigger in diameter at this point. So the pocket itself is 1 1/4 wide. So that means 3/4 is ideal because it will fit in the pocket and you'll build a helix in while still leaving stock for it. And you'll see what we mean in the coming slides. So we're going to ignore the holder. We're going to ignore the stock, make sure rest material is not checked. Inside of cut parameters, this is where it starts to get you got a little bit of minutia to deal with in more detail. So the first thing that this tutorial mentions is a step over. Okay, so by default it is 90% of the tool width. In this case, we're going to have a 90% step over, meaning we're going to be taking a lot of material or using a lot of the tool all at once. So 675 is 90% of 3/4. We're going to leave stock on the walls. That means the side pieces of the pocket. We're going to leave 20 thousandths there for finishing. And on the floors, we're going to leave 10 thousandths, which is actually interesting to me because there really isn't a floor for this pocket. Technically, I would think we just go straight through, but we'll see. Micro lift distance of 10, which is the default, and the back feed rate of 100, which is the machine maximum. So it's basically going to wrap it away from the wall when it's doing non-cutting paths. Everything else we are going to leave the same. And again, so there's some cut parameters information on number 20. I encourage you to pause the video and read through that information so that you're familiar with the reasons why we're selecting the values that we are. And then I encourage you to come back to the video and we'll continue on. So after reviewing slides 20 and 21 for the step over versus step down, I would like to now move into the depth cuts. We are going to uncheck and make sure we are not doing any depth cuts. As you read prior, we're going to do a 100% depth of cut. Because we are doing 100% depth of cut, we need to use a very specific helix motion. So we're on page 23 right now. We are going to do a helix radius, and this is a mathematical equation, so it's the feature size 1.25 minus the end mill size, which is 3/4, and then we're going to minus 40 thousandths because that is the amount of material we're leaving on the walls, 20 thousandths per side, and that all gets divided by 2. So make sure you do your parentheses first around that first part of the equation, divided by 2. So that helix radius should be 0.23. which is what we get on the PDF printout as well. So again, that is the pocket width minus the tool width minus the stock left for finish, and then divide by 2 because it's radial. So you want to put it so it's in a diameter format, and you want to turn it into a radius format. Z clearance is based off the top of stock. So Z clearance of 0.05, so that's going to be 50 thousandths above our top of stock value, which is going to be probably 0. So it's going to be 50 thou above. And now the plunge angle is 3, so that's 3 degrees. So you'll see when you click inside the plunge angle, it actually gives you a nice representation of what that is. So it's basically the travel distance of one helix. So the wider the angle, the farther down your tool will go in one rotation, one rotation of the tool path. And again, slide 24 has some information on entry motion that I encourage you to read. Go ahead and pause the video and read that real quick. Now the part about creating a projectile while machining is important to remember. There will be some cases where you think it might be faster to machine in a certain way that may leave a larger piece of stock. In general, you want to machine from the outside to the inside, and you want to remove material with the tool and not leave a chunk of stock to fall off or fall away from the tool for numerous reasons. It could get stuck in the tool. It could cause damage to the machine. In general, you want to come up with a strategy that's going to machine and create chips and not leave blocks of material to come off of the piece later on. So we are now going to move to breakthrough. As noted before, we're actually going to break through this part. It's a through pocket. So we're going to break through, we're going to turn it on, and we're going to do a 10,000ths breakthrough, 0.010, or 0.01 is just fine too. So now we're in linking parameters, and this is where we do our depth and our top of stock and all that good stuff. So our clearance is going to be an absolute of 2 again. And again, we're going to check use clearance at start and end of operation. Our retract is going to be an absolute 1/4 inch, 0.25. Our feed plane is going to be an absolute 1/4 inch to match the retract value. Our top of stock is 0. Okay, so we want to change that to 0. And that is because we've already faced off the 20,000ths of material that were existing on top of the part. So now we've established C0. And our depth is going to be absolute as well. Absolute negative 0.72. And to confirm that, I'm going to click on depth and then select the bottom of the part and see what we get for a value. Negative 0.71. So we're actually going a little bit deeper because there's still material left on the bottom to face off. So that's probably what that is. So negative 0.72 is good. As long as we have clearance underneath and we're not cutting into the work holding fixtures or anything like that, then we're fine. So that concludes our 2D high-speed toolpath. I'm going to hit apply and OK. And now I'm going to navigate back to toolpaths, and we can go ahead and backplot this feature. So I'm going to go and select the backplot button. What I'm looking for here is making sure it does not create the feature, it does not go outside the boundaries, and it also needs to be leaving material for finish. So I'm going to slow it down and start by looking at it from the top and kind of see where our tool ends up in regards to. I'm going to turn the holder off too. So there should be some material left in between the end mill and the wall, and there is. We can see that. Now we're going to watch the ramp in. So obviously the end mill has to be center cutting, meaning it can cut on the floor of the end mill. It's got a full cutting edge all the way across. And I'll just continue to let this go. I'm also going to check the right hand view and make sure that the end mill is breaking through the bottom as we expect it to. It actually looks like it is not going fully through right now. And that would probably be due to the fact that we have the stock to leave on floors, which I thought was a little weird, and that is overriding the breakthrough amount that we put in there. We'll continue to let that run. So that all looks good. We'll continue on. Again, page number 28 has some discussion points on using S and B to go back and forth and look at the beginning and ends of toolpaths. And if we actually look at the front on page 29, so it is actually looking, it is expecting us to break through, but we're not. I actually don't really like the way we're doing that. I would prefer to see us break through that. Part of it might be the fact that we're going to be facing the back of this off anyways, and that would be it. But normally I would break through farther than that, but we'll leave this alone as it is for now. I don't want to change the parameters from the PDF. So one thing that we want to do is we want to check what our final Z depth is, so we can fill that in the comment. And again, we can do that in Backplot. So I'm going to go to my right hand view and use the S key to kind of cycle through to get to the very bottom. You can change the part to wireframe too if you want to see, but I know. So right now we're at our final Z level. So we have a Z minus of 0.710, and we should be 7.720. So yeah, I think there's actually an error in the PDF. So I'm going to go back into parameters, and there should not be any stock to leave on the floors. So if you go back to cut parameters, I'm going to change that to 0. And what we should see now when we regenerate this, see, now we're broken through. So I believe that is the proper value. Now you're going to see that the end mill is actually underneath. There we go. That makes more sense. So now our final Z depth is minus 0.720, and that's correct. So I'm going to go back into parameters, and I'm going to add that value into our tool note. So we'll go Z minus 0.720. Excellent. So now we're ready to click OK, and we have our first pocket created. The next one is going to be roughing the shallow pocket. We're on slide number 31. Please take a moment to pause the video and read the overview, and we'll come right back and start on page 33. Now that you have read the overview, we're going to go ahead and machine the next pocket area. We're going to go ahead and go to dynamic milling again. We're going to stay inside, and we're going to go to machining regions. We're going to follow the same procedures last time, so we're going to use our wireframe geometry. We're going to change it to C-plane to basically dictate to Mastercam that we're using a 2D pick method. I'm going to select chain, and I'm going to go ahead and select the upper part of the entire cross section of the pocket there. Now, if done correctly, the entire top of the pocket should be highlighted in yellow. It's one continuous profile. I'm going to click OK. We are back in the chain options dialog box. And again, we just want to make sure that stay inside is selected. Open chain extension is none. That's fine. Now we're actually going to specify some air regions, and which is basically going to be the inside area that we've already cut. So we're going to move to slide number 39. We're going to click on air regions. Now we're going to select the previous chain that we did before. So we're basically telling Mastercam that this area has already been machined out, so we don't want to waste time running our toolpath through this again. So we're going to go to wireframe again, C-plane, chain, and we're going to select the bottom profile, which should be should highlight the entire chain in the bottom. At that point, we're going to click OK. You'll notice now that we have one air region and one machining region selected, which is excellent. We're going to click OK. And now we are back into our 2D high-speed geometry. So if you are having issues selecting geometry per page 41, you can move back and forth. Ensure the green arrow starts the tangency between the boss lower radius and left wall. Oh, so it's basically just saying if you click in the wrong area and it's not highlighting the entire thing, go back into the video and make sure you're clicking in the same zone. One other thing I want to mention too while I'm thinking about it. Inside of planes, you want to make sure that your Op10 G54 has all three of these planes selected on it. So WCS, C, and T. If you have these separated, you're going to get errors. We'll talk about that at a later date. What we want to make sure is when you highlight Op10 G54, hit the equal sign, and every single work coordinate plane, or every single plane, work coordinate system, construction, and tool will be equal, and you won't get errors. So going back into dynamic mill parameters, we're going to specify our machining parameters in here. So we're going to use the same 3/4 tool. So we're going to go to Tool, highlight the 3/4 rough end mill. Our comment is going to be rough shallow pocket. 0.020 XYSFF, 0.010 ZSFF. And again, the acronyms are on page 43 explaining to you what those mean. Basically, stock to leave on walls and floors. We're going to ignore the holder again. We're going to go to stock, and we're going to ignore that. We're going to go to cut parameters, and we're going to have the same step over as last time. So 90% step over. Stock to leave on walls is going to be 20. This time we have to leave it on the floors because there is a floor to these areas here. So that's important. 0.010. Micro lift distance and back feed rate are the same. So micro lift is kind of like the clearance off the floor when it's moving back and forth. More about cutting parameters on page 47. Please go ahead and read that and come back to the video once you're done. We're now on slide 49. We're going to ignore depth cuts like the last time, and then we're going to go to entry motion. There is no need to helix into the shallow pocket because the tool can feed at full depth, meaning it's only a 1/4 inch deep, so you don't have to helix in like the previous one. So we're going to go ahead and ignore that. And actually, I think we need to change it, don't we? Maybe not. Oh, we don't need to turn it off because it just won't do it. Okay. Breakthrough, we're going to turn off. That's important because we're not breaking through in this instance. Okay, so we want to turn that off. Now we're in linking parameters. Absolute of 2. Use clearance only at start and end. That's perfect. Absolute 1/4 inch for retract and for feed plane. That's excellent. Our top of stock is -2. I'm not sure I agree with that. Probably because it's going to start in the middle of the part. But I would say I believe that should be 0. I'm going to leave that at 0. I don't want to. Having a negative top of stock isn't a good idea when you're not doing features that are clear. Like this is not the best way to use a negative top of stock value. And then our absolute depth is going to be -2. Oh, that might be why. So if our depth is -200, let's double check that. We're going to click on depth and click on the bottom of our pocket somewhere here. Okay, so all right, so what this is basically saying is we're going to cut our final depth all the way through. So our top, it's going to feed down to -200, and then it's going to cut at that distance all the way through. So we'll leave that alone. I kind of understand what they're doing with that now. We'll backplot and we'll take a look at it. So we're going to go ahead and click OK. I have to regenerate my toolpath because I was messing around with it before. You should just be able to jump right into it. Now here's what I think is going to happen. So the tool is going to feed down to the depth in the middle of the part, and then it's going to go ahead and cut these areas here. So let's see if that's correct. Yep, there it goes. So that's why top of stock and depth were the same. So that makes sense to me now. All right, so it's going to cut that area out. I'll let that run. looks pretty good to me. Excellent. So again, there's some notes here telling you how to speed up the back plotting and everything else. One thing we want to do is check the back plot from the front, and we want to make sure we have stock to leave on the floor. So I'm going to go to View. I'm going to click on the wireframe button, and then I'm going to go ahead and back plot. I'm going to watch where my tool is so we can see the bottom of the pocket, and we can clearly see that it's leaving material for finish. So we're happy with that. I'm going to turn the shaded outline back on. We want to get the lowest Z value without having to go back in the back plot. I can tell you from page 56 that the Z minus is 0.190. So we'll go back in the parameters, tool, and then in the notes we will put in a Z minus 0.190. Click OK. And now we're going to be on rest roughing. So there is a nice write-up on page 58 that I'd like for you to read first, and after you are done reading that page, I'd like you to come back and continue the video. Okay, so after reading that overview, we're now going to move on to copying the rough boss toolpath per page 59. So in this case, we're going to start with number 4. Okay, so we don't want to confuse and copy number 5. I'm going to highlight number 4. You're going to see a green checkbox, and what we're going to do is we're going to right click, or we can go with the tooltip notes on the presentation here. So Control C and Control V are also the same as right click, copy and paste. So I'm going to highlight number 4 and hit Control and C on the keyboard, and then I'm going to press Control and then V, and that drop down toolpath number 6 at the very bottom of the line. Okay, so that's a copy toolpath. The reason we do that again is to save ourselves time with having to select the chains over again. So we're going to open the plus button next to number 6, and we're going to go into parameters to edit and create the finished toolpaths now. So it's dynamic mill. The tool we're going to change now to a 1/4 inch finish end mill, which is number 10 here on our list. We need to reinitialize speeds and feeds. That's one thing we missed on one previous video. So now that we select this, we're going to highlight it, right click, reinitialize, and you're going to see the speeds and feeds change. We're going to ignore the holder. Now we're going to use a different type of feature here. So inside of stock, we're going to turn rest material on. We are going to compute remaining stock from another operation, one other operation, and we're going to select toolpath number 4. So basically we want Mastercam to look at the areas that we could not machine previously because the end mill was too big. It's going to automatically calculate that, and then it's going to go ahead and machine those areas with the smaller end mill that we just selected now. We're going to go to cut parameters, and we are going to change the step over percentage to 40%. All the other defaults are going to stay the same. This pocket will be machined with 3 depth of cuts because the featured depth is 3 times the tool diameter. So the max step down will be a 1/4 inch because that's SOP, and the step over curve points us to 40%. So that's why we're changing the step over percentage to that. That's per 67 and 68 pages. So our depth of cuts we're going to need to turn on, as previously stated. And our max rough cut is going to be 0.25, and our finish step should be 0, because we're just going to do 3 1/4 inch cuts. Entry motion we're going to leave at default. I will say that our value is a little bit different than the other one, so I'm going to change the helix to 25 instead of 23. That is the last thing we need to change. Our linking parameters are still the same based off of where we were before, and our breakthrough stays the same too, same difference. So we're going to click OK. Because we modified number 6, we have to regenerate it, so I'm going to click on the dirty toolpath and click OK. And now we're going to backplot and see what this end mill does for finish work for us. So it should be getting into all the corners. It looks like it is. Again, this is because the end mill we used for roughing was too large to complete these radii. So now with the smaller end mill, we're going to do that. And because our end mill is skinny and the depth of the cut is so long, we had to do it in cut increments of 1/4 inch. So here you see clearly 3 depths of cut, and all 3 radii were completely machined. I'm going to go ahead and save this file. It's been a little while. We can check the back plot from the front and make sure we are breaking through correctly. I can tell you right now from looking at the toolpath that we are, so that's okay. Now we're going to perform the same rest rough on the shallow pocket. So again, there's a nice overview right up on page 77 I'd like for you to read through, and then we'll come back and finish this toolpath off. So now we are ready to copy toolpath number 5. I'm going to highlight number 5 and make sure that the green checkbox is on the yellow folder next to it. And we can go ahead and do the Control-C method of copying, and then Control-V. Oops. Control-C, and then Control-V. By doing that, we now have toolpath number 7. We're going to keep going with that. So now we're going to edit those parameters. So we open the plus button next to 7. Parameters. We should be able to walk through this pretty quickly. So dynamic mill, leave that the same. We're going to use a 3/8 end mill per the notes regarding why we do not use the exact size of a radius. So we're going to use a 3/8 end mill. We are changed. Yeah, I was going to say we should be changing the notes here because this note is no longer accurate here. So finish boss the walls is what the call out is. Normally, yeah, I mean normally I would say rest rough, shallow pocket, something like that. And we're not really worried about this. We're not putting the Z values in either. We should be, but it's not super critical. I'm going to right click on that 3/8 tool and reinitialize speeds and feeds. We're going to ignore the holder. We're going to go back into stock as previous. We're going to turn rest material on from one other operation, and we should be clicking on number 5. Everything else is defaults. Our step over percentage for this is going to be 70%, also due to the stick SOP and the chart we've been looking at. Our depth cuts, we do not need depth cuts for this particular instance because the end mill is larger and the depth of cut is smaller than the previous, so a 3/8 end mill can do it all at once. Entry motion is going to stay the same, and by that I mean it should be 0.25. For some reason ours are 0.23. That might have been a typo from me earlier. And there are no other changes to make. So we're going to hit OK. We're going to regenerate that dirty operation, and then we're going to run the back plot. And then again, this tool should be machining the radii, and that's it, because that's the material that was left from the previous operation. Excellent. So we can also check the front or right, either one, and see that we are still above the floor. So we still have to finish the floor. We haven't done that yet. So now we're ready to finish the shallow pocket floors, starting on slide number 96. So again, we're going to utilize the copying command, right? Why waste time repicking everything if we don't have to? We are going to take number 5. Okay, the original toolpaths. And we're going to copy it. So I highlight number 5, Control C, Control V. Now we have toolpath number 8. We're going to open the plus sign, enter into parameters. We're going to go up to toolpath type. Dynamic mill is correct. We're going to go to tool and we're going to change our note per page 98. So our note is going to be, it shouldn't be rough, it should be finished shallow pocket floor. We're going to finish the shallow pocket floor. I'm good with that. Let's see. Actually, we're going to change the toolpath type to area mill. That's going to change the way that the end mill reacts on the floor surface. So the area mill will be for the finishing pass here. We are going to use the 5/8 finish end mill per page 100, and we are going to reinitialize speeds and feeds. We're going to ignore the holder. We're not doing anything with the stock this time, so we want to make sure that that is completely gone. Now in our cut parameters, we are going to have a little bit different values here because we're finishing versus roughing. So 75% of the tool diameter is going to be our XY step over. Our stock to leave on the walls is going to be 0.010, so we're not finishing the walls yet. However, we are doing the floors. So we still need to come back and do walls after this. We're doing each one separately. And that's a stick SOP, which I believe there's some notes on coming up here. Yeah, page 104. The pocket only has 10,000 stock remaining on the floors, so 75% step over will not cause excessive tool load. But it will decrease our cycle time, so that's why we want to use a larger step over when possible. We're not going to have any depth cuts. Entry motion stays the same. We are checking transitions and just making sure that Z clearance is 0. So we want to disable this. We're going to feed straight in. We're not going to have to ramp. We're not going to break through. And our linking parameter, we just want to double check and make sure that we have 2 absolute, 1/4 inch retract, 1/4 inch feed plane, top of stock -2 and depth -2. So we're going to hit OK on that. We regenerate that toolpath. And then we're going to backplot this. So this should be machining all the floors in the shallow pocket. And I can see from the action created by the end mill just barely touching that surface that we're at the correct Z depth. And that looks good. As far as the notes go, again, I'm not too specific on the notes. I'm a little bit less worried about it. But if you want to, just copy them exactly as the PDF states. So you put the Z-200 in there, at the very least. And now we are at slide number 114. We're going to finish the through pocket walls. I'm going to click OK on this, and I'm going to go ahead and let you guys read slide number 115. And then we will continue on, and we will be starting a simple contour toolpath to finish the walls. Okay, so We are now on page 116, and we're going to go ahead and start a new toolpath called contouring. Excuse me. It's a simple toolpath. It's one of the easiest milling ones to perform. So we go to Mill Toolpaths Contour, and we are again back in the chaining dialog box. We're going to continue using our wireframe geometry to chain. So we change the mode to wireframe, C-plane, chain. We're going to go ahead and we're going to select the bottom of that pocket, the first pocket that we did. We're going to do the walls on this one. So we select that and highlight the entire bottom area. Click OK, and now we're in contouring. The tool we're going to use is the quarter-inch finish end mill, which is tool number 10 for us. We're going to we're going to add a note that says finish through pocket walls. No holder. Cut parameters, compensation type is where. We're going to have no stock on the walls, no stock on the floor. And on page 124, I'd like you to read through the cut parameters section about compensation and come back and finish this toolpath afterwards. Moving forward, we're going to go to depth cuts and make sure they are disabled. Lead in and lead out, this is the first time we're going to talk about this. So we're going to uncheck enter exit at midpoint. We're going to uncheck the gouge check. We're going to make sure entry is on. It's going to be a line tangent. The length is going to be 1/8 of an inch, which is actually 50% of your tool value. And the ramp height is going to be 0.010. The lead out, or the exit, is going to be a tangent arc. We're going to change that radius to 0.050, which is obviously a very small percentage. Sweep is 90 degrees and a helix height of 0.005. Change exit arc sweep to 180. I don't see the exit arc sweep, so that might be something that is different now in the newer versions of Mastercam. There's going to be an information page on page 128 explaining what these values mean, so please go ahead and read that and then come back once you're finished. We are now going to move on and ensure that breakthrough, my helix height was, let me go back and make sure, 0.005, one too many zeros. Okay, so our breakthrough should be turned on, and we're going to break through our standard amount of 10 thousandths. Again, we're breaking through the bottom of the middle pocket here, and that we're doing the walls. So multi-passes. So we are going to turn the multi-pass on. There are not going to be any roughing passes, so we're going to change those to zeros. However, what we do want to do is we want the number of finish passes to be 2 and the spacing 0. So it's going to take 2 passes, but one's going to be a spring pass, they call it, meaning it's not going to be taking any material, but in case the end mill has sprung away from the part at all, it just helps to establish that pocket a little bit better for tighter tolerancing. And that is explained in on page 131, so you can go ahead and read that and then come back after you finish. Spring passes are very important when you're looking for tighter tolerances and you're using tools that are close to that 3x D threshold, so definitely want to keep that in mind going forward. We want to make sure tabs is unchecked, and then inside of linking parameters we just want to double check and make sure we have the right values here. So clearance of 2, absolute, use clearance per usual. Our retract is the same as usual, absolute 25. Feed plane, same thing, absolute 25. Top of stock, negative 0.71. So that means the top of stock is basically at the bottom of the part. And then our depth, same thing, negative 0.71. And again, that should all be absolute. So we're going to hit OK. I had an error from earlier, so hopefully that clears out. Uh-oh. I'll be right back. Okay, so for those of you who are paying attention, you just saw a Mastercam crash. So that is why I always encourage you to save your files. Luckily, I already had a completed one done. Otherwise, I just lost the 3 toolpaths I just completed. So please remember to save your work. And yeah, be careful because this software does tend to crash. Not frequently, but enough that it's dangerous. So definitely try to save after every time. So going back to the contour we were just working on, we're going to backplot that. And basically all this tool is doing is running along the wall of the through pocket. I'm checking to see that it's all the way through at the bottom, which it is. And it is indeed finishing the entire wall all the way across. So overall we're in good shape here. So this is the spring pass. This is the second pass that we added. Going to let that finish. All right, and we're in good shape. So now we are moving on to the finish shallow pocket walls on the other one. So we're on page 138, and again, there's another nice write-up there I want you to read, and please come back after you are done. So we are now going to continue on by creating a new contour toolpath. So we're going to go up to Toolpaths, Contour. We're going to go back into our chaining command, and we are now going to select the geometries for the shallow pockets. This is going to be a new process for you because we're going to be doing 2 separate chains. Partial chains we're using instead of whole chains. So we're going to go to wireframe, C-plane like we have been, but rather than chain, we're going to change it to partial. So we're highlighting a partial chain. And now we are going to select the first shallow pocket area. For some reason, oh, I don't have my wireframe turned on. Sorry about that. I got to turn my wireframe back on. Oh, I lost, oh, you know what? My edge curves, I lost them on my other file, so I got to do my edge curves again real quick. Sorry about that. Let me do this real quick. There we go. So we're going to go back to Toolpaths, Contour, C-plane, partial chain. Now I can get this. So we are going to select the first half of the radius over here closest to this endpoint. That is an error that I'm getting because my planes are not correct. See that? So that, as I mentioned earlier in the video, if you get that error, this is why. So now we need to go back in here and do that again. Contour, C-plane, partial. So we're going to click on this side of the radius, and then we're going to flow that through to the end of the other radius. So there is one partial chain. Now the next one, we're going to do the same thing. I'm going to select the radius at the start over here, and then we're going to go to the end over on this side. So now we have 2 partial chain selections, skipping the middle and only having the 2 areas where the shallow pockets exist. I'm going to click OK, and now we're back into our contours dialog box. Our tool is going to be the 1/4 inch. Our notes, we can just say finish The comment's not right on this page, so we're finish the shallow pocket walls. Another note on 145 that we can pause to read and then come back to complete toolpath. So come back when you're done reading that. So per the notes on page 145, we're going to select Force Tool Change. We're going to ignore Holder. We're going to go to Cut Parameters, and we're going to make sure that we don't have any stock on the walls or floors, and we're going to change the compensation type to Wear, which we already have, so that's okay. Some more notes on page 146. I'd like you to read through that, although we've already read through that once, so that's just a copy over from the last slide about wear compensation. Depth cuts are going to be disabled. Lead in and lead out, we're going to do the same steps we had previously. So we're going to turn off gouge check and the enter and exit at midpoint. We're going to have a length of 0.1. which is a small percentage of the tool, and the ramp height's going to be 0. Arc radius 0.050, and sweep of 90. We're doing last time. Helix height of 0. Click the double right arrow to apply all lead-in settings in the corresponding lead-out settings. Oh, I'm sorry. So yes, so these values should be over here. So these should all be the same. So arc radius is 0.05, and I may have screwed that up on the last one too. So you input all of those values on the lead-in section, the entry section, and then when you click the arrows in the middle, it will push all of those same values over to the exits as well, so they're equal on the lead in and lead out. And page 152 spends some more time talking about those values. You can read through that and come right back. And we're almost done with this file. So now we're going to make sure breakthrough is unchecked because these are not through pockets. We're not going to multi-pass. The tool deflection is not going to be very significant, so we don't have to multi-pass in this case. Make sure tabs are disabled. And now we double check our linking parameters. So absolute 2, retract quarter, absolute feeds that. Top of stock is going to be the same as our depth, -2, depth of -2. That is all correct. And now we're going to back plot. I got to regenerate that contour as well. Oop. I have an issue on my other one, but that shouldn't affect number 11. I'll fix that after. So we're going to back plot number 11, and this should be, oop. Oh no, I do have an issue here. I apologize for that. I had the wrong value in one of my depths, so I had to go back and fix it. So we are back plotting the finished wall portion of the shallow pockets, and they look good. Now what we're going to do is launch Solid Verify and check for gouges. So I'm going to load a previous file because I got a little bit messed up here. So we're going to be starting on 160 to do the Solid Verify. I'll be right back. Let me do that real quick. So in order to Solid Verify all the steps we just created, we're going to make sure we go and highlight Op10 G54. All of the toolpaths should highlight with the green checkbox. And then we're going to go ahead and go up to the Solid Verify button, which is next to Backplot. We're going to make sure that our color loop is on. Everything is in isometric here, so let's run the full path here. Looks very good. So the bottom is not all the way through because there's stock on the bottom areas. Everything else looks like it's to be as expected. So now what we can do is actually use the comparator. So we are on number 164. If we go to verify and we go to compare, on the right hand side we are going to click the refresh button, and Mastercam is going to check for areas that are not properly machined. So you'll see that everything that we touched is basically in the green, and it's showing us in the middle that we still have that one area that we have not machined out yet, but that will be machined off this area here when we flip the piece over to face mill the remaining stock off. So that's basically what that area is telling us right there. Looks very good. So that's the end of this tutorial. It was a long one. Hopefully you got a lot out of this one. This is a major milestone, so if you get this one completed and you're enjoying it, then you're probably going to be in real good shape. There is a second tutorial to complete in this lab section. I'm not sure I'm going to lecture through that entire thing. I may introduce the part and then let you follow the handwritten instructions. And then also don't forget there's going to be some lab work for you this week too. So after you complete this file, make sure you send it to me via the submission link in Blackboard, and I will see you in the next introduction to the next lab or the next tutorial. Thanks.